Okay guys, this is going to go on page 24 and you can tell when it made copies it left little holes here, but this is supposed to say representing proportional relationships. So you can kind of fill in some of those holes there, okay? So we're going to actually be able to tell what is a proportional relationship by looking at a table, by looking at an equation, and by looking at a graph. Simply put, if you take any number, let's say here I have 10 and 2, and then here I have 15 and 3, 20 and 4, 25 and 5. You would be able to say this is a proportional relationship because I can find my constant by taking my y every time and dividing it by my x. So 10 divided by 2 is 5. 15 divided by 3 is 5. 20 divided by 4 is 5. And 25 divided by 5 is 5. So you can find it by dividing y over x. You know that you can look at an equation and tell, hey, is this a proportional relationship? And the answer would be yes, if it's a simple multiplying step. There is no plus or minus, and x is not being divided, it's being multiplied. Okay, so I would put on here no plus or minus, and no dividing by x. You have to be multiplying by x. And finally, you're going to know if this is a proportional relationship if it makes a straight line and it comes out of this space between the x and the y axis called the origin. So we're going to open this up and we're going to talk about these things in a little bit more detail. So if you open this up, we can just talk about some basic definitions here. A proportional relationship between two quantities is a relationship in which the ratio of one quantity to the other quantity is equal. That's right. This ratio will be equal to this ratio. Okay? I call this slash equals slash when we set up proportions. When you're talking about an equation, a proportional relationship can be written as an equation always in the form y equals k times x, where k is your constant. We'll also call it the slope or the unit rate or the constant proportionality, but it's the constant. Okay? And finally, do you remember what I said about the graphs? The graph of a proportional relationship is always a straight line. That's right. And it goes through the origin. Very simple. So let's look at this in practice. Is the relationship in the table proportional? And why? Well, let's take a quick look using our calculator. Remember what I said about dividing y by x? What is 60 divided by 1? That's right. It's 60. And all along the way, 120 divided by 2, 60. 180 divided by 3, 60. And 240 divided by 4, 60. Were they equal every time? Yes. Why? Because we took our y divided by our x, and it was equal to the y divided by the x of each of our examples. How about our equations? Circle all of the equations that represent proportional relationships. If it's proportional, identify the constant. So we're looking where we're multiplying by x. If you remember what I said over here, we cannot have plus or minus, and we can't have x at the bottom like a fraction where we're dividing by x. We can only multiply by x. So here, 12 is being multiplied by x. Here, 0.75 being multiplied by x. Here, 1/4 is being multiplied by x. Here, 6 is being multiplied by x, but they have a plus. So this one is not a proportional relationship, but all of these are, with the constant being 12, 0.75, and 1/4. Let's look at the graph. Does it represent a proportional relationship? Is it a straight line? Yes. And does it go through the origin? Again, yes. So yes, this is a proportional relationship. Here's another example. Dakota earns $8 an hour. So that is $8 for 1 hour of work. Okay, well, our X here is always the first line. It's our time, and we're talking time in hours. So 0, 1, 2, 3, 4 hours. Let's see how much he's going to make. Our Y is the money he will earn. So in 0 hours, how much do you think he earns? Right, $0. But if we are going to earn $8 times each hour he's working, that will give us our Y. So what's 1 hour times 8? 8. What's 2 hours times 8? 16. 3 times 8? 24. And 4 times 8 is 32. That is how we have a constant. Does it meet our pattern of Y equals a constant rate times a number? Yes. 8 was our unit rate, and we multiplied it to how many hours he worked. Very good. So this was simply Y equals 8x. Good job. Can we graph it? Well, if this is 0, 1, 2, 3, 4 hours, and I'm going to count by 4 and go 4, 8, 12, 16. This would be 24, skip, and 32. Now let's see. 1 hour, he earned $8. In 2 hours, he earned 16. In 3 hours, he earned 24. And in 4 hours, he earned 32. If I say at 0 hours, he earned $0, does it make a straight line and go through the origin? I would say it did. Good job, Mrs. Smith. Finally, I'm looking at this one, and they don't give me any information here, and they don't give me any information here for an equation, but they do give me this graph. And I would zoom up on this, but my phone is being balanced very delicately on something. So let's see. Ooh, if I can keep it from falling over. What do you think is happening here? I have feet and inches. It says 1 foot, and then look, there's no number here. And I will say, I feel like this is not lined up well at all. Look at this. So skip 24, skip 48, skip 72, skip 96. Okay, I apologize. I did not think that this is done very well. So the 24 and the 2 are what really connects here. So 2 feet is 24 inches. They must be talking about how many inches are in a foot. So I would say here, right, there are 12 inches in every foot in our measuring system. Because, you know, us Americans like to do things different. I know that's in cursive, so let me read it to you again. There are 12 inches in every foot in our measuring system. So let's make a graph with that. We know our X is our feet. So here's our X. It's going to be the number of feet. I'm going to say 0, and then maybe go 1, 2, 3, 4. And then if feet is our X, what is our Y? Do you remember? Our Y-axis was pre-labeled our inches. So how many, sorry about this, I've got it zoomed now, so it's a little difficult to get it in there. 0 feet would have 0 inches. 1 foot would have 12 inches. 2 feet would have 24. 3 would have 36, and 4 would have 48. Could you see that I've multiplied each time by 12? So I can say my equation is y equals my unit rate of 12 times however many feet I need. So 12 is my unit rate there. So let's see, does it match here? Okay, I'm going to risk knocking off my phone again. I'm going to zoom out. And let's take a look at this. I said that 2 was 24. Yes, it is. Here I say 4 feet is 48 inches. 4 feet is 48 inches. Very good. So, straight line through the origin, because 0 feet has 0 inches. My equation is y equals 12 times the number of feet. And there is my chart. All right, trim this up super tight to the edges, and if you do that, you can get it to fit on page 24, and it'll open up and be all there. Good job, guys.